Okay, so the next thing we want to look at here is actually a recurrence relation that uh, recurrence relation that will let us estimate a square root, and it actually gets to the result pretty quickly. Um, so, of course, nowadays we have technology that just computes stuff for us, right? Plug an answer in. But if you went back in time, 30, 40 years ago, where we didn't have mainframe computers in our pockets like we do now with our phones or even calculators. Pocket calculators were really a big thing too much 50 years ago. They were just really starting to come around. So to estimate a square root by hand, there's actually an algorithm for doing roots of a number, but it's pretty involved. Whereas this gives us a quick way, as we're going to see when we do some examples here, to compute square roots pretty quickly. So the first thing we do in our recurrence relation is we make our initial guess of the square root. Hey, I'm going to guess that it's c. Of course it's not. Square root of 8 is not 8. Right? Square root of 8 is not 8. But then what we do is the next value, we average our previous guess with the fraction that's generated when we take c divided by our previous guess. Okay, when we take c divided by our previous guess. Right? That's what we're looking at here. Okay, so we use that as a way to kind of work the problem out. And as you're going to see, this works pretty well. So let's just look at it. Let's just use our recurrence relation here to approximate the square root of 2. So let's approximate the square root of 2, which, by the way, first few digits of square root of 2 are 1.4142135, and so on and so on. Okay. But we're going to see that our approximation is actually going to be pretty darn close to this, and we only have to do a couple of steps. So if you've ever looked up the algorithm for computing the square root of a number, you know, then to get this answer here would take that algorithm 2, 3, 7 steps, to get those digits. And that would take quite a while with that square root algorithm, square root process. But here we're going to use this recurrence relation. So we estimate it by saying that A0 be the thing we're trying to take the square root of, 2. Then using the recurrence relation, A1 would be half of 2 plus, then we're trying to do square root of 2, which is 2, divided by our previous guess, which was 2. So 3 halves, or 1.5. So after one generation of our recurrence relation, we've gotten closer than we were previously. And we repeat this process. A sub 2 would be 1/2 of A1, which is 3 halves, plus 2 divided by 3 halves. Well, it turns out 2 divided by 3 halves is 4/3. Okay. And if we add the fractions, 3 halves plus 4/3, and then take half of that, we will actually get 17/12. 17/12. As a decimal, 17/12 is 1.416 repeating. So you can see now that we've gotten the first 2 digits of our number down, 1.41. 1.41. Okay, so that's just after A2. And then we're going to do the same process again to compute A3. A3 Well, I'm just going to punch this into a calculator here at this point. So 1/2 times my first guess, or my last guess, which was 17/12, plus my value 2 divided by 17/12. And so I get this decimal here, which, by the way, as a fraction is 1 and 169 over 408. 1 and 169 over 408, which is actually 577 over 408. But the decimal value, you can see 1.41421. We've now gotten the first 5 digits of the number only on the third attempt. Okay. We're going to kind of stop with that one. Again, that would be as a mixed number, 577, or improper fraction, 577 over 408, which again as a decimal is 1.4142115, and so on. So you can see it agrees in the first 5 places now with the actual square root answer. So this converges really quickly. Gets there quickly towards it. It's approaching it really quickly in just 3 steps. Okay? And we can do the same thing for any other square root. Let's just look at a second example real quick here. Now this one I'm going to mostly just do on the calculator, so I can just keep using my values, my previous value off the calculator. So square root of 10, let's look at that one. So my initial guess, of course, would be 10. The next one would be 10 plus 10 over 10, which would be 11 over 2, would be 5.5. We can do those ones easily by hand. And then the other ones, I'm just going to use my formula again. 1/2 times 5.5 plus 10 divided by 5.5. And there it is, 3.659. I'm just going to go with that decimal approximation for my list, 3.695. And now I'm going to use that previous answer. On mine, I can use this last button, or I can just click that button. Click my previous answer and bring it up. 1 divided by 2 times the last value plus 10 divided by the last value. On your graphing calculators, when you're doing this computation, let me just do real quick here. 1/2 times 5.5 plus 10 divided by 5.5. Oops. So there's my 369. On the graphing calculator, you can do it as doing 1/2 times. You can do second, the minus sign to pull up your answer, plus, oh, no, shoot. I'm going to go back, sorry. Redo that again. Try this again. 1/2 times parentheses second answer plus 10 divided by second answer. And there's my third value, 3.196. Okay, same thing I get here. 1/2 times. Why is that division by 0? The last wasn't 0. I'm not sure what's going on with my calculator here, why it's not taking that. I should have done that. 1 divided by 2 times the last value plus 10 divided by the last value. For some reason it had forgotten what the last value was, I guess. So 3.196. You can see it's 3.196. And again, on your graphing calculator, you can use the answer button as a way to do that as well. 3.196 to 3 decimal places. The actual square root of 10 is 3162. So we're off here. It takes a little longer because 10 is further away from 0, further away from 1. But you can see here that we are getting closer. 3196, 3162. Right, we're getting closer. Just we're not there yet, but we're getting closer. Okay. So that's just an example of using a recurrence relation to approximate square roots.